धीरे धीरे बोलिए। आप किसी को बहुत पसंद करते हैं लेकिन बोलने की
Where? Good evening, sir.
Good evening, madam.
Sir, shall we start the session, sir?
Okay, am I audible?
Yes, sir. Yes, sir. Audible, sir.
Okay, my screen is also sharing, right?
Uh,
Yeah.
yes, sir. Yes, sir.
Okay, okay.
Sir, 1 second, sir.
Yes.
We'll start with the session with prayer, sir.
Okay.
Okay, sir. I call Bonita to lead us a prayer.
Dear God, we come today to bow our heads and open this meeting in prayer. Loving God, we glorify and thank your name. You have showered us with so much blessings, and your presence remind us of your faithfulness and guidance. We ask that you would bless our speaker, the bishop of our institution, principal, staff, and students, and that you would bless our time together today. May we grasp those things that you want us to understand. May our hearts always be ready to respond to you and your wisdom. We humbly ask you to shower our speaker today of your greatest inspiration, so that he may share most of his knowledge, heart, and soul to his respective topics. May we also observe the knowledge experiences and put it into practice. We pray these things in Jesus' name. Amen.
Followed by prayer, call Tamil Ilakiya for Bible reading.
James chapter 1 verse 5. If any of you lack wisdom, you should ask God, who gives generously to all without finding faults, and it will be given to you. This is the word of the Lord. Thanks be to God. Amen.
Thank you, Tamil Ilakiya. So now welcome speech and speaker's intro. I'm Professor Geeta Kumari. It is great pleasure to welcome our honorable speaker, Dr. S. Sampson. Welcome you, sir. I wish to welcome our beloved principal, Dr. Joshua Gnanasekaran. Welcome you, sir. I warmly welcome our PG coordinator and convener of this program, Professor M. Angeline Felicia. Welcome you, ma'am, and extend my warm greeting to all the participants. Dr. S. Sampson, Professor, Civil Engineering and Chief Engineer, Weltec Group of Construction, Weltec, Rangarajan, Dr. Saguntala, R&D Institute of Science and Technology, Avadi, Chennai. Sir has completed his undergraduate civil engineering at University of Madras, Government College of Engineering, Salem in the year 1987. In the year 2002, he has completed his postgraduate structural engineering at Periyar University, Government College of Engineering, Salem. Sir has completed his PhD in the groundwater source at PSG College of Engineering, Coimbatore, Anna University in the year 2011, and is research interested concrete strength and durability, water quality characterization, GIS, and remote sensing. He has been appointed as various positions like worked as a teaching lecturer in various colleges in the year 1993 to 2001. Worked as an associate professor, civil engineering at KSR College of Engineering in the year 2005 to 2010. He worked as a professor and head of the department in civil engineering at Mahendra Engineering College in the year 2010 to 2016. He is working as a professor right from 2016, Department of Civil Engineering, Weltec, Rangarajan, and Dr. Saguntala, R&D, Institute of Science and Technology, Chennai. Sir has published many papers in national and international journals. Also, Sir organized several guidance for PhD and ME projects. He has published patent in the topic, a method for evaluating groundwater quality. and also participated national and international conference, seminar, workshop, etc. Thank you. I would like to hand over the session to Honorable Speaker.
Thank you, Ms. Lisa. First of all, I like to thank the principal, Dr. Joshua Gnanasegaran, and the convener, Dr. Kelshia. And I thank CSI Group of Institutions, CSI College of Engineering for inviting me for this webinar. I'm very much delighted to be being a part of CSI member. I'm very much delighted to handle this, webinar on smart materials and smart structures in civil engineering. Thank you, Dr. Joshua Gnanasegaran, for inviting me. Okay, shall we get into the presentation? The screen is visible, right?
Yes, sir.
Okay. Today's topic, the smart material and smart structures in civil engineering, is an important topic because in our institution level and our engineering college level, people are not at all worrying about the smart structures and smartness in the civil engineering. They simply take projects in concrete technology and the steel structures and other, water quality and environmental engineering. Because the future is only for the smart structure. Because everywhere, the automobile industry or in the, in any industry, not in the communication industry, everywhere the smartness is advancing. But in case of civil engineering, the rate of advance in the smartness is very, very less. So the future will have smart structures. The future structures will be of smart structures. Without smartness or without smart structures, the applications in the civil engineering area is very less. So it may be better for all civil engineering graduates or undergraduates or postgraduate students to undertake projects in smart structures, because in concrete and steel areas, all the areas are saturated. You cannot find a new area to proceed for your research. Whereas in the smart areas, you have got a wide opening and you can go for many projects under this category. Let me introduce, today's presentation will have, four parts, maybe the introduction, what is in the smart materials and mechanism of smart structures. Another thing, the applications in to civil engineering. So you have this many parts. So let us get into the first introduction and the smart introduction. Then we'll go to other parts by one by one. What is smart? One minute. No, not disappearing. Smart structure is a structure that monitors by itself. It controls by it diagnoses each level and it is acting accordingly. Smartness is nothing but it is any damage comes to the structure or any changes happening to the structure should be capable of monitoring it or understanding it and acting accordingly. Okay. For example, for the very example for smart civil engineering structure is the bridge structure. So the bridge is capable of giving you this much of information as shown in this slide. Too much traffic is over the bridge. The weather condition is making me unsafe. My reinforcements are weak. My deck is cracking. The truck coming over nearer to the over coming to approach the bridge is overloaded. The bridge is some distance some other voices are coming, madam. Okay. Hello, am I audible?
So right now audible, sir, but it automatically getting disconnect audio, sir.
No, some other, new voices are coming in. That's why I'm asking. So I am
So I
using,
request all the participants, please put your mic off.
okay. I'm using two devices. One is laptop, another is mobile. So unmute unmute my, you cannot, the presentation in slide mode, please unmute because I'm speaking through the laptop. Whenever in some device, the slide will be showing, right? In the slide mode device, you please unmute. Okay. Uh, till the bridge is kept because this much of informations are needed because this much of suppose in some times of flood or in times of some abnormal conditions, abnormal conditions, and the river may be flooded, the bridge may be over it, and that when it is flooded, the government may not be interested to allow all the vehicles; it will allow one by one. So it maybe it will allow too much of it will not allow all traffic to pass through the bridge. So in those things, suppose it is all controlled now by human being because the traffic control over the bridge and other and they are going for a periodical checking and we are going for a periodical maintenance of the bridge because under the bridge sometimes and it may be unapproachable. So under the bridge, so if the bridge is giving you this much of information, the weather condition is not good. The weather makes me to corrode my steel. My steel is being corroded. My deck is cracking. Another thing that vehicle which is approaching the bridge is overloaded. If the bridge is capable of getting this information automatically, then it is a smart bridge. So it is required because all the time by 24 by 7, we cannot control over it. At the same time, now we are going for skyscrapers. Structures are very tall. We are going for very tall structures. Um, in those cases, suppose people person has to first think about the external painting or external cleaning. If anything is if any damages in the very high floor, maybe 15th floor or 20th floor, it is not climbed to that high to check the condition of the structure. So, what we do, we just send a drone or a camera attached drone and we are monitoring the structure. So in those things, in sending the camera and getting the information now through the camera and analyzing the condition of the external condition of the tall structure, this all smart structure activity. So for example, in a house, and if you're all sitting inside a room, if no one is sitting there, the light automatically the light should go off. At the same time, we are switching on the AC and we are setting a temperature. Suppose if I set a temperature so that your room temperature is 5 degrees cooler than the atmospheric temperature. So based on that atmospheric temperature, the AC temperature will be varying. At the same time, when you switch on the light, even in the bright light, you can alter the intensity of the light. When you open the door, bathroom door, the light should be on, or the exhaust fan should get on. At the same time, when you come out of the bathroom, the light should off, and the exhaust fan should stop, like that. So those things are some of the very example in our day-to-day life. Sometimes, if we are using, we are now we are, every in every house we are using overhead water tank and we switch on the motor every day. After that, whenever we find some water is coming out of the overhead tank, we switch off the motor. Electric pump, electric motor. Suppose if there is any mechanism so that the light, the water level goes beyond such some defined level, so the water pump should automatically switch on. If the water level is reached after reaching some level, the water pump should to switch off, like that. If you have this kind of control, then it is, of course you can say it is a smart control. So in the day-to-day application, the same way, then day-to-day application, if you are capable of controlling whatever all the things you are controlling. So if it is all controlled by some system, it is a smart system. So how to implement that and how to make that is a question mark. So it is of course integrated with electronics, computer science, and mechanical and electrical. So all this, all area of civil engineering, all areas of other engineering will get into the civil engineering. So it is sensors are there, computer science is there, electronics is there, electrical is there, mechanical is there, and it is all getting into the civil engineering structure. So in other structures, other areas also, a smart structure is being used. In aerospace engineering, it is very, in aeronautical engineering, it is very much, without smart structure, the aeronautical engineering will not survive. So, I mean, the damage detection, vibration control, shape control, adaptive structures, I mean, all these things in the aerospace engineering are all smart structures. I'll explain one by one. And defense also, fine, I mean, the defense will, I will list some of the points. I'll, in the slide to come, I will explain all those things. So I mean, mostly the the vibration control, adapting wings in the aircraft and rocket, all these things are controlled by smart structure. Okay, 1 minute. Okay, then aircraft. Let us see about the aircraft. As aircraft is the highest form of the smart structure, where you could find this. The pilot cannot take control over all those things because the noise control and other flutter suppression and other there are so many things because the aircraft flying is not it's an extraordinary engineering. So an aircraft may be around 200 to 300 ton. It is taking that much of weight to 35,000 foot above the ground level, mean sea level, and it is slowly taking up to that level and slowly getting down to that level, ground level, and it is not at all making any shake. It smoothly flies. So this is an extraordinary engineering. So all these things are maneuvered only by the smart structural application. Okay, first thing in the wing and in wing there must be some small adjustment should be there. Otherwise, the pilot can raise the aircraft and lower the aircraft by its control, right? And small fluttering, like the butterfly wings are, the fluttering. Those kind of fluttering. Suppose due to that, there may be some imbalance in the aircraft flying, and it will not fall down. It will have some shake. So those small adjustments can be done with the help of that smart tracker so that the flaps in the aircraft wing will be automatically adjusted so that it will have a balanced flying. And it will have so much of vibration because an aircraft engine is rotating with very high speed. Otherwise, it cannot make such jet of air. Jet engine and other propeller engineering, propeller engines are making high with the rotations in the engine is very high. So that due to the high rotation, it will be having so much of vibration. So the controlling the vibrations inside the passenger cabin is very difficult. Sometimes there must be some actuators so that some shock absorbers have to be strengthened up. So it need not be strengthened all the time. It has to be according to the vibration. If the vibration is coming abnormally. So based on the air pressure and the air pocket there in the atmosphere, the vibrations will vary. So due to those sudden changes in the atmospheric air pressure and if the vibration is also changing, so that vibration should not be transferred to the passenger cabin. So for that, we have got so much of control unit in the aircraft. Okay, so taking up, pilot does the major job, but small things the pilot cannot notice and pilot cannot operate small things. So those things can be controlled only by the smart application and smart structure. And in case of this rocket or missile engineering, and we'll have some rigid fins there. And rigid fins are made up of smart material because it cannot be rigid all the time. It has to warp and it has to adjust because when it is fired towards the target, there may be some little correction in the in its path should be given. So little correction, some imbalance will come. So little corrections are to be done. So those things cannot be. No pilot is there, and it cannot be. It is operated from the ground. So the wing itself is made up of some warping material. That warping material adjusts its spin, and it will twist or adjust its spin so that it flies towards the target. So this, the whole body and the whole setup is made up of some smart material. Okay, the smartness, without smartness, this warping cannot be done. And in automotive engineering also, I mean, in case of automobile engineering, we have, I mean, in the present cars, in the olden cars, the older car will have only the engine, headlight, and tire, battery, that's all, and doors and seats. But it will not have some sophistication. When you look at the present day car, it has got so much of sophistication, so many features are there. In it's internally, I mean, GPS and other things, so many features are there. So avoid, I mean, neglecting those things. The car itself, in the mechanism itself, will have so much of features. Like they have, I mean, shock absorber, or I mean, for the power steering. I mean, power steering is not about just a power steering; it is electronically assisted power steering, and vibration control and temperature control. These are things which you are not controlling. It is automatically done by some of the smart devices attached to that. So the car will become, when it is adjusting everything, say for the road is bumpy, and automatically it will strengthen the shock absorber, so that I mean it will, the vibration from the road will not get into the passenger cabin. And at the same time, if the road is not bumpy, I mean, if it is going on a plain highway, and it will have some less effort on the, I mean, shock absorbers, so that car will not jump due to, suppose if shock absorbers are very hard in sense, car will jump even when it is going through the plain road. Suppose if the shock absorbers are rigid, I mean, even the bumpy road, the shock absorbers are somewhat rigid, then only it can withstand the bumpy road. So like that, the suspension mechanism will be altered by itself with the help of the smart material. So it is there in the automobile engineering also. In medical application, smart structure is very much, I mean, nowadays, when you get into the, any hospital, the hospital will be having so much of electrical equipment, electronic equipment. So it will be looking like almost, I mean, electronic lab. So around the, around the patient, you can see so much of equipment. One will have a control over its heartbeat, other will have control over its pulse rate, and others have control over, I mean, so much of control over units are there within that. Okay, without electronic equipment, the day has come. Without electronic equipment, you cannot treat a patient. Everything is monitored: blood pressure, blood glucose, heart rate, everything. Everything is temperature. Everything is monitored by the electronic devices. All devices are smart devices. Okay. In civil engineering, we have got extensive application in.
நாளைக்கு சுபமுகூர்த்த தினமாங்க. நாளைக்கு நீங்க அதனால மகேஷ்ட பேச்சுவார்த்தை நடத்திருங்க. சரியா?
Please mute the participant. Can you please mute your mic? So it is disturbing the others also. I'm very sorry to say this. Okay. So this is in civil engineering application. We have seen, I have given you some of the examples, but we have got so much of examples and so much of things. So this, I think this is enough to for introduction part. So let us move on to the smart materials. Without smart materials, we cannot make the smart structure. What are the smart materials available, and what are the role of, I mean, smart materials? We'll see one by one. Okay. The smart materials are working based on the stress, temperature, its moisture, and pH level, electric fields, and magnetic fields. So some of the several external stimulus, even physical events that stimulate the smart material. So these are some of the physical events that stimulate the smart material, so that the smart material will come into action. So under this, we have got this much of material. First one is the piezoelectric material. Second one is the electrorestrictive material. Third one, magnetorestrictive material. Fourth one, rheological material. Thermo-responsive material. Chromic material. Fluorescence. Fluorescence is nothing but I'll tell you. This is of course a tough material. Biomimetic material, and it will mimicry the biological thing. We'll just see. Smart gel, shape memory alloy. Piezoelectric material is a very common thing, and in computers you could see that without piezoelectric crystal, the computer will not function. So when it is pressed, it will emit some electrical signal. When it is mechanically pressed, it will emit electrical signal. So when it is released electrical, it will be, the electric signal will be disappearing. So change of application of pressure over this crystal will generate pulse. This is the piezoelectric material. Based on this piezoelectric material, and people now have started generating electricity from the piezoelectric material because it is laid in the on the floor below the tile. When people are walking over the tile will be pressed. So once the tile is pressing, it will be generating pulses. Those electric signals, the electric pulses are collected and it is stored for, in the battery. For, it is the electricity is being generated from the piezoelectric crystal that is embedded below the, floor tile. This project is going on now. Studies are going on. It has become success, and many people have got awards in this under this particular research and project development. Other material, the electrorestrictive material. Electrorestrictive material, this material has the same property as piezoelectric material, but the mechanical change is proportional to the square of the electrical field. Here it is also same thing, electrorestrictive material sense when there is a mechanical change in piezoelectric material also. Piezoelectric material when it is pressed or compressed, it will be generating pulses. Here if there is if we change just change the shape of the material, it will generate electricity. This is electrorestrictive material. So electrical just change in the shape will generate electric material. This material is also used in the application of the smart structure. Other one is the magnetorestrictive material. Magnetorestrictive material is nothing but it is opposite to the electrical field. When you change magnetic field and some magnetic, mechanical strain will be produced or mechanical change will be produced. When you produce mechanical strain, magnetic field will be produced, and that magnetic field will be converted into the electrical field. Then it will be applied. So electricity and magnetism are interrelated. Without magnetism, electricity cannot be generated, and when the electricity is there, magnetism can be generated. So when magnetism and electricity are interrelated, so this is the reverse application of this. Electric field, you can say in this way. It is interpreted or it is analyzed in this way. It is analyzed based on the magnetic property, where that, in the previous case, it is analyzed based on the electrical property. And magnetic property is, some of the devices have been developed using the magnetic property also. And rheological fluid. So this is based on the flow pattern. So there are some of the material or liquid phase which can change the state instantly through the application of an electric or magnetic change. See here in the diagram, this is the magnetic fluid, and if there is any change when a magnetic field or electric field is introduced here, and this pattern arrangement the flow, arrangement will be changed like this in the bottom diagram, the bottom picture. So whenever, say for example, too much a crowd is coming. So if one or two people are coming in front, so it, when they are passing through any floor or any sensor or fixed floor, a piezoelectric sensor or any other electrorestrictor, magnetorestrictor sensor fixed floor, and it will produce some some electricity will be produced. So if you give this to this particular material, it will create some flow pattern will be changed. Understanding the flow pattern, this flow pattern can be interpreted to how many people are coming or what load is coming like that. So it will be interconnectedly it will be used. So the flow pattern or the molecular arrangement will be changed in the rheological material. And thermo-responsive material. Thermo-responsive material based on the heat. Heat is a stimulus thing here. Heat based on the heat, the color of the material will be changed. See, for example, so when it is cold, it is dark in color. If it is warm, less dark and less white and bright. And if it is hot, it becomes very bright. So based on the color inside the cup, this is a smart cup, of course. If it is cold, if it is, if it is white in color and it gives you an alarm that it is in the very hot liquid is there, the hot drink is there. So you can wait for some more time. Once it gets cold, you can drink like that. It is giving an alarm. So this is another picture based on the press Suppose if you place a hand based on the press, color is changing here. So at the same time, I mean the color is used to indicate the temperature here. This is another. This is suppose if the color is used I mean this material is called a thermo-responsive material because based on the heat. Madam Geeta,
Yes, sir.
am I audible?
Yes, sir. Yes, sir. Right now only.
Hello, am I audible? Madam?
Yes, sir. You're audible, sir.
Yes, madam. The slide is not changing here. It is got stuck here. 1 minute, shall I correct it and come back?
Okay, okay, sir.
It's not changing. I mean, it is stuck here. I'll go out and come back, right? Or you
Okay,
are
sir.
presenting from your side?
Sir, I'll ask with my administrator, sir.
Okay, okay, okay. Slide is not changing here. That's the problem.
Jerry, sir.
I'm okay, ma'am.
Okay, sir. Okay, sir.
Ma'am, I'll share the screen, ma'am.
Okay, thank you, sir. Thank you, sir.
I'm very sorry for this because it never happened. It is the first time it is happening like that.
Which slide, sir?
1 minute, 1 minute. Okay, it's visible.
Which slide I have to move, sir? Hello.
Yes, yes, yes. Oh, go to full screen mode.
It is in full screen, sir.
Slide presentation mode. Slide mode. Slideshow mode, slideshow mode.
Okay, sir.
No, it's not changing.
Now, sir.
Slideshow, full screen, full show.
Here it is show, sir. Full screen only it is show, sir.
No, sir, it's not changing.
Bottom there is a one bell button. You have to press that button. Then it's a slideshow mode come.
Yes, go to next slide. Slide was there with the cups and other thing. Go to that slide. Yeah, there. Okay. The previous slide. Previous slide. Okay. I was talking about the thermo-responsive material, right? So thermo-responsive material is nothing but the color of the material will be changed based on the thermal input. So when if it is dark, we can suppose when it's hot, it is giving you bright illumination, and when it's cold, it is giving you darker. It becomes darker. So this is a thing with the thermo-responsive material, and this is also used to indicate many things to alarm the people. This is being used to alarm the people, to understand the things, to make awareness to the people. So thermo-responsive materials are used. Next one. Next slide, please. Okay, next one is this electrochromic material, right? Electrochromic material is nothing but this is the ability of the material to change in color. So in LCD screen, say there are so many crystals, so we are making the color picture color image by altering voltages to this crystal, small crystals. We are changing that color picture. So this is what happening in the LCD TVs and LCD displays. Each crystal is giving different voltage, so that it is producing different colors. As a whole, the different collection of the different colors is creating you the image. So this kind of technology is also used in smart material. It's called as electrochromic material, or used to with when there is a you want to create some color change, they'll be changing the voltage or changing the optical property and electrical property, so the different colors will be appearing. So this electrochromic material. This is another advanced material called as fluorescence. The pronunciation, pronouncing the word is very difficult one. This is of course making a hollow ball. Say it is a net-like structure made up of the carbon pentagonal. Polyhedral structure. Each part will be a pentagon or hexagon. It's making some ball. So this is a hollow system, maybe a cubic system, or like a ball or cubical system. It is called a spherical gauge. This is of course made up of some carbon molecules or carbon atoms to be arranged in such a way that it is making some kind of gauge system, and after that it is making some hollow system. This is applied mostly in case of electrical, biomedical and medical application. medical application, this particular thing is becoming very very more high application is there in the medical field, and in case of high conductors and superconductors and optical devices also being used. Next, please change the slide. Change the slide. Next one. This was about the thing that I was talking to you, telling you. Next slide. Okay, this is of course another thing. It is called as biomimicry. Nothing but mimicking. I mean, mimicry, right? And after seeing some people are acting as with reference to other, or they are simply repeating the actions of the other, and they are making fun. It is of course it's called as mimicry. This condition here, it's also, I mean, we are using this mimicry technology, biomimicry technology in material also. Say a leaf. What is happening in a leaf? Leaf changes or turns towards the sunlight, right? Leaf changes towards the sunlight to absorb the sunlight. So based on, we are getting this idea. We can and we have started using this idea, that is changing the shape or acting according to the response, acting according to the need, is the biomimicry material. So we have got some materials also based on, working like the biological material. So we are using this material also. Go to the next slide. And a parachute, you can compare, a parachute is a technology, it is an invention based on some of the biological application. You could see this kind of plant which is coming down very slowly. This is, of course, this ideas that are arrived from this kind of, seed or flower or something. We have seen that in our, in field, where you are in Uti, in hilly area, you might be seeing this very often. And the elephant trunk. So elephant trunk, the trunk is, of course, it is what is that? Is bending and holding like that. So this kind of thing is in robotics and other things. You hold a material if it is in a remote place. Yeah, with the multiple connectors, with the elbows and the joints and multiple connectors may not be helpful. So this kind of technology is used to hold a material in the remote place. So this is, of course, replica of the biological system. So this is acting according to the biological system. It is called as the biomimicry material. Okay. Then smart gels. This is, of course, a gel. Go to next slide. Okay, some of the things, it is a gel which can absorb, which can shrink, or which can swell. So this kind of technology in gel, you use in smart, the development of the smart materials and smart structures. So this is, absorbing and shrinking and getting, swelling. So this technology, this is being absorbed, and these, the mechanism behind this understood for the application development of the smart material. Next slide. We are talking about some of the smart material. So I'm giving you, so what are some of the top materials and smart applications of those things. And this is another material called the shape memory alloy. Shape memory alloy is nothing but it will remember its shape. So when you stress the material, this will deform. Once you remove the stress, it will come back to the original material. So we have studied some of the elastic material. Once you pull the material, when you load, the material will be extended or stretched. Once you, leave the row, release the load, the material will come back to the original position. That is what the elastic material. Here, this is almost like elastic material, because the material may have different shape. When you distort or deform the shape, it will come back to its original shape. It will remember the shape. So this particular material is called as the shape memory alloy. Okay, this is on this material very much used in civil engineering. Okay, the next slide. Okay, what are the we have studied some of the material, piezoelectric, electrorestrictive material, magneto-restrictive, and thermoelectric, shape material. Photochromic and thermochromic material. What is the input given actually? What is the input given to that material, and what is the output we are getting from those material? Let us see. In piezoelectric material, the deformation or the mechanical change is given. The output we are getting is the potential difference or any, voltage difference. Your voltage pulses will be generated. And electrorestrictive material, potential difference is given, deformation will be observed. Magnetorestrictive material is magnetic field is given, deformation is observed. In thermoelectric material, temperature is given and potential difference is observed. In shape material, temperature or informative force, if the temperature is given, deformation will come. It is not all the time. When deformation is temperature release, it will be automatically, vice versa. And when you apply, change the shape, and it will come back to think that is the main concept behind the shape material. And photochromic is radiation is given, color change will come. And thermochromic is temperature is given, color change will come. These are some of the inputs we give and inputs we get, and it is of course reversible. It can be applied in reverse mode also. Next slide. Then we are going to study about the mechanism of the smart structure, how it works. So the next slide, please go to the next slide. Please move on to the next slide. Smart structure incorporates mechanism. Previous slide. A smart structure incorporates sensors and actuators into the material of the structure in such a way that enables the structure to sense its environment and then respond appropriately in a programmed manner. So without sensing and without actuation, the smart structure in civil engineering will not come. So we have to observe a change. Once you have observed the change, it has to be diagnosed and it has to be processed. After that, some remedial action has to be taken. So a smart structure, it is being based on this mechanism. Something is sensed. The sensed thing is diagnosed. Based on the diagnosis made, something is processed. After that, some remedial action is given as an output. That remedial action is activated at the other end, be some physical movement or any other required move. The change. So sensing and actuation, observing and acting is the mechanism of smart structure. First thing. Move on to the next slide. To have to perform this particular thing, we have got some steps. First one is the data acquisition. Whatever may be the change that is coming in, or if it is a deflection, or if it is a strain, or if it is a change of shape, if it is a vibration, that data has to be absorbed with the help of some sensors. So the sensors will absorb the data, and after that it will be transmitted from the sensing end to the other end, because the sensors may be at the bottom of the bridge, or it may be in 14th floor or 15th floor of a tall structure, or it may be inside the water at the bottom of the dam, inside the water. So sensor may be fixed at any part wherever we require. From that sensing end to the main unit, the data has to be transmitted. So the sensing may be optical, maybe optical units, or it may be resistant, or it may be whatever the thing, maybe electrical signals or a digital signal, analog signals or digital signals, or it may be optical signal, whatever may be the signal. So that observed signal has to be transmitted using some transmission technology. So that is the process of transmitting the observed signal to the processor. It is the data transmission technology. This is the second stage. Third stage is a control unit. So the first stage is of course tactile sensing. It is of course observation. Second is like nerves, our body, and nerves are taking the thing like that. In transmission line or transmission mode will be taking the data, and in the control unit, the brain, it is a processing unit. Based on the observed data, it will be processing what to do, what is the thing has come, what kind of action we can take. Those things will be finalized in the command and control unit. And in the next, I mean, here the data instruction or the motor nerves, I mean, biologically speaking, it's the motor nerve. So the command of brain will give you the instruction so that this instruction will be passed to the actuation device and action device. It's like a muscles, and there the actions will be taken. So it has got 5 stages. Right? So these are all the 5 stages of operation are called as the component of the smart system. Next slide. Okay, the mechanism is described here in this way. First thing, sensor, control, and actuator. So it is all by, I mean, once the actuator, it's all interconnected. Once it is sensor, it senses the control unit. Control gives command to the actuator unit. Once the actuator has achieved its job, it is again giving back the signal to the sensor and it is being controlled. Once activating, doing the job and stopping the job and controlling the job is also there. So these things are interconnected, these units are interconnected, then the smart structure mechanism is functioning. Okay. Now let us see, to go to the next one. I mean, let us see sensors. How do we do the sensing technology and other things? So what is meant by sensors and what are the different types of sensor we'll go see. And this is sensing technology is the very first thing. Without sensing, nothing can be. So sensors are very, very basic unit, first unit or for any kind of smart structure or smart system. So this effectiveness of sensor, effectiveness of the smart structure depends on the effectiveness of the sensor. Okay, next slide. Next slide. Okay, what are the different types of sensors available? One is the point sensor, another integrating sensor, other one is the distributed sensor. So point sensor is nothing but it will be located, concentrated only at one point. One point, sometimes they're measuring the temperature or measuring temperature in your body. It is pointed to only one point. Sometimes, the second type is the integrated sensor. So it will be few sensors will be connected in maybe in a line or it may be in a pattern, indefinite pattern. It will be connected, and this, the data from different points will be integrated. So this is called the integrating sensor. And distributed sensor, it will spread all over the particular area. Maybe for example, you want to measure air pollution of a city. So the air pollution sensor, sensor that is monitoring the pollution will be spread will be fixed all over the city, so that the pollution level at various points in the city will be taken into consideration. After that, it will be processed, and some other actions will be taken. Like our CCTV camera, which is fixed all over the city, and based on that camera, we are controlling everything, right? So this is, of course, a distributed sensor. CCTV camera across the city is, of course, a distributed sensor. Please, next slide. Next slide. Okay. So whatever may be the thing, the basic technology we use here to diagnose the thing is, of course, the Wheatstone bridge that we have studied in our basic electrical. So we know the Wheatstone bridge is having 4 resistors connected across, arms like this, as shown in the figure. So here we have got PQRS 4 resistors connected across the bridge. A change in the galvanometer will show you what are the changes coming in, right? First, the galvanometer is made straight, right? But there is the resistance. S is, of course, a variable resistance here. The galvanometer is showing null deflection. Once, say, for example, if you remove any resistance like PQR, you attach the deflectometer or the sensor that is giving you the resistance change. Sensor that is connected to a device, and device giving you the resistance change. So you are giving a resistance stage across removing one resistance here. Maybe let us say, for example, let us remove Q and connect that the signal from the sensor here. So it is in the form of resistance. So the galvanometer will show some deflection. So interpreting the deflection shown on the galvanometer or calibrating the changes in the galvanometer, we can find out what thing is happened here on that side. So basic thing, whatever may be the sensor thing, that sensor thing will be converted into an electrical signal in the form of the resistance change. In the form of resistance. That resistance will be collected across a bridge, in a Wheatstone bridge. Across instead of one resistance, will be connecting that signal coming from the sensor to a Wheatstone bridge. And Wheatstone bridge will produce some change. That change will be calibrated or interpreted in terms of the required thing. So Wheatstone bridge is the very basic circuitry that is being used for the smart structure. Then next slide. And I have told you, this is what about we have studied about the sensor. Then the actuation part. Actuation part is concerned. So we are sensed something and we have processed something, and it is to be taken into action. It is to be acted. So once we go for the action, and it is actuation. That particular unit is called as the actuator. This is controlled release of the. For example, controlled release of. For example, we in our car. We are using the braking system. The braking system is of course. It is of course an actuator. Once you see something by your eye, it is using sensor. Your brain processes, and the brain gives you command to your leg to press the brake pedal in the car. Once it is actuated, the brake drum will be maybe with ABS or anything else, and drum will be acting inside the wheel so that the car wheel will stop. So we are not suddenly releasing the full energy. We are pressing the brake pedal according to the requirement. If it is if any person is very close, we'll apply brake suddenly. If it is very, if you want to stop in the signal, we'll apply very brake slowly. So it is of course controlled release of energy. So eye senses, brain controls, leg apply. So the leg is the actuator, brain is the central processing unit, and eye is the sensor. So like that, the controlled release of energy is of course called as the actuator technique. Okay. So this is of course evolved from the biological model. So for example, action device is given here, load is applied. So the load is applied. There is one. How do you see? I don't know. Okay, load is applied here. Downward arrow shows the load is applied. It is to be negotiated, or it is to be made zero. So the control unit is getting signal, a load is applied from there. So the control unit is giving electrical field, and an opponent actuator is placed at the bottom. So the actuator makes pushes up, and it makes zero. So from the downward load, it is made zero in 10. From the control unit, an electrical field is applied to the actuator at the bottom. It makes it to zero. So this is of course a block diagram of an actuator. So when you remember the car and braking system, it may be easy to understand. Okay, next slide. Okay, so this is the classification of smart structures. We have got 5 classification: adaptive structures, sensory structures, control structures, active structures, and intelligent structures. So in general, basically, and everything is, first classification is adaptive structure. It is coming in the, outer ring. So the most intelligent structure is the highest form of the smart structure is placed at the center. It will be involving all. And then the peripheral thing is the active structure. Other thing is the control structure. Other one is the sensory and adaptive structure. So these things, this is the order of the smart structure. The classification order, you can say. And then moving on to the next slide. Applications in civil engineering. Move on, next slide. So few commonly encountered smart material civil engineering applications are: first thing, piezoelectric material, shape memory alloy. And here we are, let us see along with the civil engineering here. Magnetostrictive material, magnetorheological fluid, self-healing material, structural health monitoring material. Sexual health monitoring structure. First thing. So, for example, the very best example for smart structure in civil engineering is the transport system or the road system is the very first thing. Because of, when a vehicle is approaching, this is the widely used or very commonly used smart system. Say, for example, a weak bridge or a bridge. So you want to control the load over the bridge. So we are inserting piezoelectric crystals on the road, and at some before 1 kilometer or 2 kilometer the reach of the bridge. And excessive vehicle is a vehicle with excessive loading is coming in front. So the piezoelectric crystals will be pressed. After that, it may give signal. So the vehicle will be stopped before it approaches the bridge. So this is the very basic, very common application in the piezoelectric system. Civil engineering, and the piezoelectric materials are very commonly applied. And we can have this kind of application. We can this kind of based on the crystal, based on this mechanical crystal. We can have this kind of application anywhere. Okay, even for example in a lift. Lift says too many people are loaded. They say lift may be designed to carry 10%. If 12 people are 13 persons are getting into the lift, what it says, overloaded. So lift will not move. So this is done. This is absorbed only from the piezoelectric crystals. Okay. Next one. Shape memory alloys. Shape memory alloys are extensive application in in bridges. You can say shape memory alloys. Okay, 1 minute. Shape memory alloys are the thing that remembers. You can move on to the next slide. Please move on to the next slide. Okay, I've already given you some of the example because it remembers the shape. After that, it is regaining its shape. So this is the basic application of shape memory alloys. I've given you very good information about the shape memory alloys. Before. So now let me go to the diagram. Please skip the slide. Let's go to the skip the slide. Okay, take care. For shape memory tendon, shape memory alloys as a tendon in concrete structure. Let us see this. What is written here? Where SMA have the ability to being pressed without any tensioning devices. Okay. In concreting, pre-stressing will be using, pre-tension. The wires will be tensioned before the application of the load, so that it is, 1 hour it is stressed. The already stressed wire will handle the stress very easily. That is what the concept of pre-stress in our civil engineering application. Here also, shape memory alloy tendons are used. So once we have to give the application of the tensioning forces to the pre-stress cable here nowadays in regular construction. So once it is tension, it is of course the pre-stressing applied there, and based on the tension in the cable, I will be taking the tendon. So the tendons, if any wire is tension, what will happen? It will bend. So we are recording that bend to that wire. So it, that remember its shape. So why even after you remember, suppose it remember the shape. When you apply load, the shape will be distorted. After that, it will again come back to the original shape. So this kind of remembering the shape, it is used here to negotiate the stresses also in case of pre-stressing. So you have here in the very first class and in the very first information, just remember, once the how would the stressed wire behave is recorded in the shape memory alloy wire, so that by remembering the shape, it is negotiating the stress. Just remember to that extent that it is enough. We have one diagram in the slides to come. I will explain using the diagram. Okay, please keep the slide. Okay. So this is a bell tower of a church in Italy. So it is, of course, made up of brick structure in the very wood structure. The retrofitting has been done with the help of the shape memory alloys. Here, the load limits in the masonry, and the shape of the masonry structure is made to remember, and whenever the load, is excessive due to the wind forces and other things, and the shape is maintained. So the retrofitting technology has been done with the help of shape memory alloy. And how do they gone for the retrofitting and all? You can just go Google it, because it is a church in San Giorgio of Italy that is retrofitted using the shape memory alloy. So the deepest, if you want to know more about the application of shape memory alloys, how did they recover the particular church tower, then you can search it on net. Let us move on to the next slide. Okay, next slide. Next, we'll have a diagram. Okay, here you see, it's the bridge deck slab, and what is, due to thermal stresses or due to the temperature stresses will come the bridge. In the thermal, in sunny days, in the hot temperature, the bridge will expand. In cold temperature, the bridge will contract. So thermal stresses will produce some kinds of ups and downs. At the same time, in the road, you can see this kind of thing will make the bridge slab to come down or go up due to the thermal stresses. So when you go to travel through, approach the bridge, you could find some bump in the entrance. So it will go either go down the road level or come up against the road level. And shape memory alloys are used to maintain the original shape. So even after thermal stress, and it will keep the bridge in the same level. So this, here you are applying the shape memory alloy in highway. So initially the road is in the pavement, or the bridge is in the road level. So due to the thermal stresses, the bridge will go down or come up. So this is a distorted. When going down and coming up is a distorted shape. The original shape is kept in the memory of the tendon fiber, so that it always, if there is any thermal stresses, it always keep to maintain the bridge in the original level. So shape memory alloys are used here to maintain the bridge in the same level. Next slide. So this is self-healing. So this is a biological system in smart structure. Self-healing is, of course, suppose if you get any wound, what happened? Our wound is automatically healing, even if you don't apply any medicine. After some time, the wound is healing. So same type of mechanism is being now practiced in concrete also. If there is any crack, the crack will be filled. So we are using for bacterial concrete for this. And this mechanism, this kind of thing is being practiced in biological system. The biological idea is practiced in the civil engineering. So for based on the self-healing material, they are filling the cracks. That research is also being going on. So this is self-healing idea is, we have taken this idea only from biological system. Okay, this is, some of the materials used for the self-healing or smart material. Next point. Okay, in biological system, say for example, we are standing on both legs, right? Suppose we need not stand on both legs all the time. Whenever when one fold one leg, or when we lose one leg, what will happen? We have to stand on the other single leg. So by nature, the single leg is capable of taking the whole weight. At the same time, when we are standing on the both legs, only a half load is coming to one leg. So whatever may be the position we stand, our leg is capable of taking the load. The same way, whatever may be the stretch, whatever may be the change in the physical change in the structure, the available column and available beam should be should be made to take the entire load. So that idea is from the biological system. It is taken to the civil engineering system also, and it is being implemented. It is being practiced in the project level. And so we have got several openings for this for new projects also in this area. So all these biological things like here, light, sound, and all biological things, and healing, changing the load, and we can sit at any position, or they will not be disturbed. So based on the sitting position, the load will be transferred. The same way, you can, if you alter the structure should be capable of adapting to the new system. So this is the biological system. So we are developing projects under this category. So this system will be in future, it will be implemented everywhere. Okay. Next is structural health monitoring. Structural health monitoring in sense, for example, in civil engineering structure is getting weak and develop crack. So there is due to the application, it will develop crack, right? The structure is weak, it will develop crack. Am I audible?
Yes, sir.
Yes, sir.
Okay. Am I audible?
Yes, sir. Yes, sir.
Okay. In any system, the structure will develop crack. So in structural health monitoring, if any optical fiber is used, if you insert an optical cable inside the slab, or suppose if there is any, any crack is developed, the optical fiber will, sense that crack and it will tell you. So before the worst thing happening, and we can sense the cracks and other things. So this is what the structural, health monitoring application. So we have got so much of, applications in civil engineering, like application piezoelectric material, shape memory alloys, magnetorestrictive, and other things, self-healing, and other self-monitoring applications in civil engineering. So with this, I want to wind up today's presentation. I've given you some of the introductions about the civil engineering material, and introduction about smart structures, smart material, and how it is acting, the mechanism of the smart structure, and its application in civil engineering. With this, I'd like to wind up. Thank you very much for giving me the opportunity.
Thank you, sir. Really, it's a very useful talk for us, sir. I would like to end up the session with a word of thanks. It gives me an immense pleasure to deliver the word of thanks for this event to all dignitaries assembled here. I would like to thank our chief guest, Dr. S. Sampson, who honored this function with his inspirational thought. I would like to thank our management, our beloved principals, staff members, students, system administrator, and last but not least, our beloved participants for making this event as a grand success. Once again, I thank one and all present here. Thank you, sir.
Thank you very much, madam. Thank you.
Dear participants, I have attached the feedback link. Please fill up the feedback link and send it to us.
Madam, shall I
Thank
leave?
you once again. Sure, sir. Sure, sir.
Thank you. Thank you.
Thank you, sir. Leave.